It sounds like there's like all these other sort of that kind of put in place.
I mean, so there's some people that
Oh, so this is yeah.
How are you doing? How are you? That's something they say,
well, that's because they have that. You can train somebody, you can show somebody not to tie into a smokestack. You can show somebody how to tie into it. No words.
Yeah. There was something with chicken.
My name is Adrian Dayful. I'm a consultant on training and labor issues. This has been a great symposium in terms of hitting all the certification and safety issues around solar. I just hope that everybody keeps in mind the performance of solar, how these systems do in terms of payback for their investors, in terms of the long-term performance. Are they generating the electricity that they claim to be? That, to me, safety is a subsection of performance, because in the end, the solar experiment in Ontario is going to be judged based on, did these systems do what the manufacturers and the installers said they would? And obviously they have to be safe, obviously they have to be of high quality, but unless it hits the output that is being promised, that is how people will judge the experiment in Ontario. So I hope that when all the stakeholders involved look at this, that they realize that performance is the most important factor.
You're talking about performance of the panels.
Performance of the panels, did the financial performance, did those people who invested in both microfit and fit projects, did they get the return that they thought they would? Mm-hmm. Did the province get the megawatt generation that they projected? Those are going to be the markers for success. Have we increased our solar energy capacity in Ontario? No. And number two, is it financially viable? Unless we can do those two parts, safety is down the list. Safety becomes an integrated part of performance, but it is not the lead issue for what will make the Ontario industry a success.
Isn't it also based on how much sun Ontario gets on those panels? It's not just the panels themselves, it's also how much sun hours are going to, you know, do you know what I'm saying? It's not, I mean, you can't just say it's the panel's performance when there's sun, there are cloudy days, there are days of rain without sun.
A lot of those issues are identified in the design phase, in the system, what kind of system is best for what particular site. That's where you do your shade analysis. That's where you do all the calculations to make sure that you have the best system in place for that location. And again, that ties into performance. as long as all those criteria are identified and calculated, that's when the performance will come through. So that is really the lead issue, I think, with the industry right now. Safety is certainly important. Make sure that it's done to it's a marker that, yes, we're doing this properly, we're doing it to a quality, but overall safety is one leg of the three-legged stool. It's safety, it's quality, and it's performance.
Yes.
Certainly. My name is John Salmon. I'm a master electrician and a licensed electrical contractor in the Kitchener-Waterloo area. Our company focuses a lot on electrical installations in industry as well. We're involved now in solar PV. I also serve as the Contractor Industry Standards Representative for the Electrical Contractors Association of Ontario, as well as the Contractor Industry Standards Rep for the Canadian Electrical Contractors Association. So as part of my role, I serve on many CSA committees, as well as working with government to work on concepts such as new governance over things like solar PV in terms of who ought to be doing the work, whether or not it's electrical work, and the rationale behind saying that electrical work is done by electricians and whether or not some of the other solar PV work can be done. So what I found interesting about today's presentations were we certainly had an opportunity to hear from people with their perspective, maybe for example what the other side is thinking. There were some excellent points brought up. The main theme seemed to be whether or not there should be a separate and new trade for solar PV. We've contended all along that the electrical trade can easily handle the installation, service, and wiring of the systems that are solar PV. We also believe that with our apprenticeship program, that under that direction we can keep costs within control, and that's part of the reason that we've had apprenticeship. The gaps that we're actually seeing in this industry where the focus should be on the designers, the people that would write specifications, go to the site and review site conditions, determine the actual irradiance and the offering that solar PV can have in terms of delivering the correct amount of solar radiation and solar electricity to the grid. As well, there will be opportunities in the future for people to do solar repair. So there'll be this equipment will break down, so there'll be maintenance requirements and things of that nature. So there's a lot of work to go around, and there's a lot of opportunities out there that I think if we move forward with these sorts of conferences where everyone has a chance to speak. It was excellent to see government people here. That certainly was probably some news for people in terms of their own safety requirements. We heard from legal advisors. So we had a chance to get a very well-rounded opinion. I like the fact that we had some various roundtables and people had an opportunity to see where is the industry going based on where we are today.
Okay, I have a question that I was trying to ask. How do roofers fit into the collaboration of the installation? Because the roof, I mean, the panels have a certain number of, there's a certain weight to the system, right?
Yes.
And the structural soundness of a roof before the actual installation. How do roofers come into as tradesmen into this?
Okay, so there are several other trades as well as professions that are involved. So at the onset of solar PV, engineers, and typically structural engineers get involved, look at things like snow loading, wind shear, attachment points, the extent to which we need attachment points, and they produce drawings that are at a design and for construction level. So the roofers and oftentimes the glazer trades, the glass trades, they would work from the specification that they would find from the engineer. So they would know what size brackets to use. That wouldn't typically be something that they would just choose and, for example, subjectively say, I think we should use this size. So it's a multifaceted group of people that get involved. So there's laborers oftentimes that carry panels, roofers that make sure that when there's attachments points being added, as well as cones being put in the roof where electrical penetrations take place to make sure all the waterproofing is intact, and make sure that things are on the roof are done and that the snow loading is done correctly, because that's another consideration in Canada. In the wintertime, when the panels become covered with ice and snow, they can become quite heavy, and there's a concern that there could be roof collapse. So the roofers are involved in making sure that they install their hardware based on their trade understanding of that typical hardware. So let's say, for example, we were installing an air conditioner on a roof or a generator on a roof. The same types of rules apply to solar PV that apply to those systems as well. So there's good engineering practices. The workers review the drawings, they follow the drawings. The engineers and designers come to see that the drawings have met the specifications. The authorities having jurisdiction, such as the building inspectors, the electrical safety authority, though all those people come out and inspect the work and ensure that the work's done by the various trades is done so properly. So it does take a multidisciplinary team to do a proper solar PV installation, and that's where the industry is moving. So we're all learning. There's a lot of codes and standards that need to be written. We're working on all that stuff right now to get a better understanding of how these systems ought to be put in.
Okay, thank you.